Good morning, one and all. Today we are taking the rapid revision on the BXC subject. As we know that the exam is upcoming within 10 days. So for that purpose, we are taking the rapid revision on the basic electronic engineering subject, which is from the first year engineering under the SPPU. So first unit name is the diode and application. What is the diode? What its application? These are its content which present in the unit number first. So what is the diode? The diode has two terminal, anode and cathode. The definition of diode, basically it is made by the two semiconductor material. First is the p type and second one is the n type. It allow the current flow only one direction. It means the forward direction current can be flow. As we can see the diagram of the diode, there is a p type and there is a n type of a semiconductor. When p is connected to the positive terminal and n is connected to the negative terminal, we call as a forward bias. It means supply going to pass throughout of that diode. There is a one region is formed, deflection region. When it is in the forward bias, the deflection region is reduces. At the end, it is the break and current flow throughout of that. And the reverse bias means that p semiconductor connected to the negative terminal and n type of connected to the positive terminal. It means the reversible we have to connect is that the deflection region, the width going to increases to unable to electron flow throughout of that. So we call as a reverse, because it is called as a reverse bias. So next, the VI characteristics of PN junction diode, how it is work in the forward bias. There is a one knee point. We can see that it is made up by the semiconductor material. It means by the 0.2 and 0.7. It is a cutoff point. The knee point in which the diode going to turn on. As we can see, this is nothing but the knee point. Below the 0.7 we call as a cutoff region. Below the 0.7 and 0.3, it's made up by the silicon and germanium. It is a cutoff region. The diode, it is in the turn off condition. After that 0.2 and 0.7, it is going to current is rapidly increases. As we know, already we have learned in the practical. Am I correct? The second, it is a behavior. It is a very little current flow at after the threshold voltage, and 0.7 and 0.3 the current increases exponentially with the voltage. As per the graph we can be observed. The second, what is the reverse bias? Reverse biasing means the supplying source. When the positive terminal is connected to the n side and the negative terminal is connected to the p side, already we have learned, we call as a reverse bias region. And reverse bias, the work diode is in the reverse bias. Second, the half wave rectifier. What is the half wave rectifier? At the output side we are getting the only half cycle, so because of that we call as a half wave rectifier. So it has one input supply, one transformer, one diode and one load resistance as per shown in the diagram. When we AC supply fed to the transformer is used for convert AC into AC. We know the function of the transformer. It is a step up and step out the voltage as per we require. And there is a diode. It is connected to positive, and P is connected to positive and N is connected to the negative. Its work and the positive, or A is positive with respect to B, then its work and the positive and current is flow, and A is negative as with respect to the B, the voltage cannot be flow throughout of that. The waveform as per shown in that, as per you can see the only we are getting the half cycle, or it is a full cycle. We can see the full cycle, and the only one half cycle we are getting at the output side, because we call as a positive, because we call as a half wave rectifier. And at the negative half cycle it is work and the reverse bias, so at the output side we are not getting any type of a output. So second is a full wave rectifier. Why it is called as a full wave rectifier? Same concept we can be used here. When we fade to the full cycle, at the output side we are getting the full cycle, but it is rectified, the work is convert AC into DC. At the output side we are getting the full DC full cycle. So full wave rectifier is a convert AC input into the pulsating DC. There is a pulsating with some impurities present inside of that. The full wave rectifier is categorized into two types. One is the center tap, and second one is a bridge wave rectifier. The firstly we will see the center tap rectifier. It is center tap because the transformer is divided into two parts. When positive half cycle D1 is turned on and negative half cycle D2 is turned on. Already we have learned in the theory section how it is. So it is so positive half cycle one diode is conducting, and negative half cycle second one diode is going to conducting. As you see, as per that we can see the waveform. There is a positive half cycle, there is a one diode going to forward bias, it means the D1 diode going to forward bias, and negative half cycle there is a D2 body diode is in the forward bias, and the positive first half cycle D1 is a off condition, and here is a D2 and a on condition. As per we can see, already we have learned in the theory section. Second, bridge wave rectifier. Already in the bridge wave rectifier we are using the 4 diode D1, D2, D3 and D4. In the positive half cycle only 2 diode going to turn on, and negative half cycle any 2 diode. When we are writing at the theory exam, that we have to mention that the positive half cycle, when we fade to the positive half cycle, we have to show here A1 and it is a B. So when we are given the positive half cycle, A is positive with respect to B, then which one? D1 and D2 going to turn on. And same when in the negative half cycle, B1 is positive with respect to A, then after D4 and D3 turn on. What about the D1 and D2? D1 and D2 is a turn off, because they are going to they are not conducting, because there will be the reverse bias. So this is the waveform. Already light emitting diode. It is made by the gallium arsenide, gallium arsenic phosphide. So it is a symbol of that LED. How we will get the photon? As already we have learned in the physics. So there is a two region. One is a the light emitting diode. Already we are familiar with the LED. We are using that LED in the home appliances everywhere. So working of LED, there is a one conduction band and valence band. When the electrons jump from the valence to the conduction band, and when they return back, there is a emitting some energy in the form of the photon. So at such a way that we will get the light at the output side. Second is it's a symbol of that photodiode. It is a semiconductor device, semiconductor component as well. Already we know that the photodiode is convert. It's a one type of component which convert the light energy into electrical. It is used in the street light. The working already it's work in the reverse bias. When the light is emitting on that active region, the electrons moves toward the n type and holes move towards the p types, and the current flow throughout of that. Because of light energy is converted into electrical energy, photodiode. The transistor technology, what is a transistor? It has a three terminal base, emitter and collector. There is a two diode. It's scientifically overlapped or connected to the each other to form a transistor. We can see that PNN, NPN, PNN, NPN, the two it has a three terminal. Its work as a switch, its work as an amplifier as well. It is a current control device, and MOSFET is a voltage control device. How it is a current control device we will learn. Its work and the three mode: active, saturation and cutoff mode. Active mode means J1 and first one is a forward bias, J1 is a forward bias and J2 is a reverse bias. Then its work as a active mode. Saturation mode, J1 and J2 both are in the forward bias, and cutoff region, it means that the J1 and J2 is the reverse bias. Its work and the open switch. Second, VI characteristics of that. VI characteristics, BJT of common emitter, already we will learn. Why we call as a current control? Because that there is a input is a IB. When we are fed to the input supply, the as per the base current, the collector current going to control by that input base current, because we both are the collector current is controlled by the IB. It means the base current, because we call as a current control. And there is a MOSFET, the VGS is there, and that ID current is controlled by the VGS, means gate to source. So MOSFET we call as a voltage control device, and BJT we call as a current control device, which use as a switch, which use as an amplifier. It's the input its work as the same PN junction diode. We can see that P, N and P. N2 is the input. It's same work as a PN junction diode. There is a one knee point after the 0.7 and after the 0.2. It will be the turn on, and rapidly current going to increases. As per we can be see the VI characteristics, that IB current is nothing but the control the IC, and in IB current, it is nothing but the input current is control output of IC, and it is nothing but the VC. So there is a IB is controlling, it means the base current going to control to the transistor. So because we call as a BJT is a current control, BJT is a current, BJT is current control. The same we can be see in the how the BJT is work as a switch. VCC is equal to VCE, and when the in the cutoff region, both junction and the reverse bias is work as a open switch. When the saturation is a post junction in the forward bias, it's work as the closed switch. So as per we can see that already we have learned in the theory section. There are the two type of transistor, N type and P type, already we have learned. The deflection and E MOSFET, enhancement MOSFET and deflection MOSFET. There are also two type, P type and N channel of MOSFET. We will learn that. The operation already we have seen in the theory section. The MOSFET is also work in the three: cutoff region, ohmic region and saturation region. It is nothing but the ohmic region. It means it's provide it's provide the resistance. So because it's called as a, it can be increase or decrease the resistance. So MOSFET is work as a resistance as well. It will use as a saturation, and below it is nothing but the cutoff region. It means that the MOSFET it is in the off-in condition. So it is made up by the semiconductor material. The we can be change or increase or decrease the ohmic level, means the threshold value. So it is work also as a switch. The VGS is greater than VT, it is work as a turn off, and VGS is less than VT, it is work as a turn off. So it can be used as a switch as well. We can see here same thing. There is a VLSI, very large integrated integrated circuit. It's nothing but the way that VLSI, that same technique it's used in the IC for the manufacturing IC. So in that case, that VLSI technology we can be use the MOSFET, CMOS, because the MOSFET is work as a switch. It's require very small power consumption. So because of the CMOS and MOSFET we can be used in the VLSI. Typically more than 1000 of transistors we can be used in the per chip. Foundation and of modern of microprocessor and microcontroller of FPGA. CMOS technology, most common low power high speed design. Silicon substrate based material is used for the fabrication chip. EDA tool, electronic design and automation software used for the VLSI circuit. What is the advantages of the VLSI? It is used for the high performance, very low power consumption is required, compact size, very less small size we can be used in the VLSI. So for the example of integrated circuit, everywhere we can use the ICs. We are all the familiar with that. How it is a different fabrication technology and method, how we can be manufacture that N-well of CMOS. First formation of N-well, then after define the N and PMOS of active region, then we have to oxidize, then after form the polysilicon, P-type diffusion, N-type diffusion contact, then after we can be form the N-well of CMOS process. It is nothing but the fabrication. What is the logic gate of digital circuit? Logic gates, there is a divided in the basic gate, derived gate and universal gate. The basic gate is categorized of OR gate, AND gate and NOT gate, and derived gate XOR and XNOR gate, and universal gate is nothing but the NAND gate and NOR gate. Why it is called as a universal? Because by using that gate we can be implement any type of a gate. So it is nothing but the binary, decimal and octet number. Binary, it is only 2 digit, we are using the 0 and 1. Decimal number 0 to 9, octet number 0 to 7, hexadecimal 0 to 15 number we can be used for that. As for that conversion, already we have learned that if we have to convert binary to decimal, we have to multiply by base of 2, and we have to convert decimal to binary to, we have to divide it by 2. Firstly we are considering the decimal point, we have to divide by the which number we have to convert it into decimal, that base number is that. These are nothing but the example. What is the logic gate of AND gate? When the two input are different, output is low, we can as the AND gate. When the two input are different, output is high, we call as a OR gate. What is the NOT gate? It is the inverter, whatever we are giving. The XOR gate, when the two input are identical, output is low. XNOR gate, when the two input are identical, output is high. Same as a NAND gate and NOR gate, it is a reversible of AND and NOT. The De Morgan theorem, what is it? If the complement of the function, the complement of the product is equal to the complement of individual, and the product of summation is equal to summation of product is equal to the complement of individual product. It is nothing but the, it's already we have proof that in the class. It is a very easy or very simple theorem. Second is the logic circuit, half adder and full adder. Basically half adder is nothing but the we can be add the logically add the two number, the two input. It has two input and two output. The output is just one sum and one carry, 0 0 0 1 1 0 1 1. When the addition of 0 0 we get the 0 0 1 1 1 0 1 and 1 1 0, and at the end we are getting the carry 1. And when getting the 1, where is we are getting the 1? The product of A and B, the summation of that we are getting the uh, A complement of B and B complement of A. It is at the output side we are getting the XOR gate and one AND gate, and we can be designed such a way that same thing full adder as well. It has a 3 input and two output was sum and carry. Input is 3 bit we can be add, and at the output side we get the sum and carry. The same thing we can get the flip-flop, the cross connection of two gate, maybe NOR, NAND, and at the output side we are getting, when it will be the set 1 and 0, and it will be the reset 0 and 1 value. Already we have seen that logic operation of that. JK, same thing, 0 1 we are getting the reset and 1 0 we are getting the set. What is the difference of that flip-flop? Both flip-flop is a 1 1 value we will getting the toggle, and if there is a PSR flip-flop 1 1 value, it is a invalid condition. Same T flip-flop, it is a toggle case. When we are getting the 1, at the output side we are getting the 1 1, it is a toggle. And the D flip-flop, it is used for the on and off condition. For the on and off, when 0 1 there is a 0 and 1 0, it is going to set. Same the microprocessor we call as a heart of the computer. The microprocessor block diagram, it consists of ALU, control unit, and register array, memory unit, and input. ALU is nothing but the arithmetic logical unit which used for the performing the operation of logical and or NOR, addition and subtraction. Control unit is nothing but used to control that, and different type of register is used for the performing the operation. Where is the application? It's used in the laptop, mobile, embedded system, and automotive system. The function of a microprocessor: fetch, decoder, and execution and store. It has three function. By using the three function, it work the microprocessor. Second one is a microcontroller, or inbuilt it present the ROM, RAM, timer, serial input output, and it is same work as a microprocessor, but it's having its own memory, serial, and A to D converter. And the application is used in the home appliances, industries, automotive, and IoT. The new start with the operational amplifier, op-amp. It is nothing but the one type of IC74. We can be used for the generating the waveform, triangular waveform, square waveform. It can be used for the inverting amplifier and non-inverting amplifier. We can be add, subtract, digital oscilloscope, digital power supply. Where is the application of that? The block diagram, it's a input म्हणजे dual input stage, we can be convert dual input balance output. Intermediate stage, it convert dual input into unbalanced output. Level shifting emitter follower with constant current source. Output a complementary symmetrical push pull amplifier, and at the output side we are getting the perfect output of that. Second thing is the ideal and practical values of performance. Already we have learned. What is the inverting amplifier? Is a basically configuration where the output of 180 output phase is gives to the input and provide. It has one input resistance R1 and one feedback resistance. Why it is called? It is give the output feedback to the input. R2 is nothing but the feedback resistance, and output is nothing but R0 is equal to minus RF upon R1. Already we have learned its derivation. Same, it's nothing but non-inverting. Its a phase shift is 0, we call as in phase, and its output is 1 plus RF upon R2 upon R1. Digital multimeter is one type of instrument. We can be measure the different type of a component, current quantity, voltage quantity. The block diagram of that, it consists of one rotary switch, buffer amplifier, calibration attenuator, current to voltage converter, current to converter, calibration attenuator. Buffer amplifier, it is nothing but the one type of a rectifier. Here is a calibrate attenuator, also one type of a rectifier. It convert AC into DC, and at the output side it has one rectifier to convert the DC supply. Then after there is a current to voltage converter is there. We can be convert current quantity into the voltage quantity, and at the end there is a one analog to digital converter, and then after the digital counter is there, and after that we can be display the value of that. Function generator is nothing but one testing instrument. We can be generate the different type of a frequency, sine wave, cosine wave. There is a block diagram. It consists the triangular generator, is means the integrator is there. It converts the triangular generator. It the same here is we are getting the output is a triangular, is a square wave. At output we are getting the square wave, and it is a output is we are getting the sine wave. It directly connected to the amplifier is given to the signal, and at the output side we are getting the different type of a waveform. Digital storage oscilloscope, we already familiar with that. It is used to test the instrument, capture the display, analyze electric signal over a time. Unlike to the analog oscilloscope, it digitalize the signal for the storage, processing and display. But actually it contains input signal, then it's amplify that, digitalize is convert into digitalization. It may be the sampling form and quantization form. It's store in the memory, then analyze that form and reconstruct that waveform. It is nothing but the vertical section and horizontal. There is a triggering time based generator and horizontal amplifier, and at the display we can be appear the different type of a waveform for the analyze purpose. DC power supply, it may at the output side we are getting the regulated DC power supply. The input is in the form of AC. Transformer convert AC into step down AC, then it fed to the rectifier. It may be half wave, full wave, bridge. It convert into pulsating DC. The filter, some impurities present of DC, it's removing by the filter. And voltage regulator, it's regulate the perfect, supposed to be we want to 12 volt, perfectly 12 volt regulate. It's that and any type of that, it's an example of that. It's used for the perfectly regulate, and then voltage divider, and at the output side we are getting the perfect DC supply. Thank you for that.